Sequences including the nth term. Here is the sequence of numbers. Now the dots at the end indicates that the sequence doesn't end. It will go on forever. However, often with these questions, when you're looking at sequences, you will just consider the first few terms. Now looking at the first few terms, I can see to get from one term to the next, you add 2. So to get from one term to the next, the term to term rule would of course be add 2. Now this term to term rule is very useful and it will allow us to find the next terms in the sequence of numbers. So the next one will be 17, then 19 and so on. However, it is very useful to find a rule in order to work out any term in the sequence, say the 50th term. Now you could keep adding 2, however there's a much quicker method and this is called the nth term formula. Now let's consider the sequence before and we're going to list each number with a position. So term 7 is position number 1, term 9 is position number 2 and so on. Now please note that n stands for the position number. That is where it is in the sequence. Now that we have the position number for each term, we need 2 pieces of information. Now they are the difference between the terms, which we've already found out is +2, and then the imaginary term before. Now what that means is if there was a term before the first term in position number 1, that would be, as you can see the difference is 2, it would be 5. Now with these two numbers, your 2 and your 5, you're going to multiply the difference, which is 2, and you're going to add the imaginary term, which is 5. Now, what does that all mean? What it means is the rule, in order to find any term in the sequence, is you multiply the position number by 2, and with that answer you add 5. So let me demonstrate it with one of the terms from above. So if I'm looking for the third term, so that is position number 3, I will multiply the 3 by 2, which gives me 6, and then I will add 5, which equals 11. And as you can see, that is the term number. So let's do that one again with position number 5. So n is 5, and you multiply the 5 by my 2 here. So 5 times 2, which equals 10. And then I'm going to add my 5 on, which indeed is my term number of the 5th term. Now that we've seen how it works and that we can find any term in the sequence, let's look at putting it into a formula. Now the formula is going to be called the nth term formula, and the first thing we do is we write down n, then with the times by 2 I bring that down and multiply it by n. Now don't forget n is the position number, so where it is in the sequence. And then the second thing I do in the formula is I bring down the +5 and you add it on, as I demonstrated in the previous slide. Now this is almost the nth term formula, but obviously in algebra we'd never leave 2 times n. So we change that to 2n, and my nth term is 2n plus 5. So just to recap, my nth term formula will allow me to find any term in this sequence of numbers as long as I know the position n. And it's 2 comes from the difference and the 5 comes from the imaginary term before. Now what often you will do is you will just check that it works with one of the numbers in the sequence that you've been given in the question. So let's check the fourth term. So it should be 13. Let's just check that my formula is indeed correct. So let's substitute in my 4 because it is position number 4. And we do 2 times 4, which is 8, plus the 5, which of course is 13. And that is what we're looking for. So it is correct. Let's have a look at this example. To recap, once we find the difference between the terms, we're going to multiply that number in the formula, and once we find the imaginary term before, we're going to add that number in the formula. So the difference is plus 3, so that means I times by 3. Then if you go back to the imaginary term before, that is minus 1. So I'm going to add the minus 1. So the rule is I'm going to multiply by 3 and then add a negative 1. So putting that into the formula, I bring down my times by 3 and my minus 1. So that's 3 multiplied by the n, and then you add the negative 1. Now, if you can remember from a clip on number, that a plus and a minus written right beside each other become a minus, so I can rewrite this nth term formula as 3n minus 1. Now let's just check one of the terms above. So let's check the term in position number 5. So my n will be 5, so bring that 5 down and put it into the formula. So 3 multiplied by 5, because n is 5, is 15. Take away 1 is 14, which is correct. It was 14. So therefore, it is correct. So let's look at this last example. So first things first is we have to look at the difference between the terms so we can multiply that number. So the difference you can see is plus 5. So we'll put that here because we're multiplying my n by 5. Then the next step is I have to find my imaginary term before. So the difference is 5. So if I go back 5, the imaginary term would be minus 4. So then I bring that minus 4 down and I'm going to add that negative 4 in the formula. So we have 5 is multiplied by my n, and my minus 4 is brought down and added. Now don't forget, when you add a negative number it's just negative. So my nth term formula is 5n minus 4. Now once again I'm going to check one of the terms above to see whether my formula is indeed correct. So let's check the fifth term. So we'll check the fifth term. Don't forget n is 5 and it should be 21. So we have 5 multiplied by 5 is 25, minus the 4 is 21. So my formula is correct. Now it's your turn to answer some questions. Pause the video and then try these. How did you get on? Here are the answers. If you answered any incorrectly, have a look back through the video and then have another go.